Good afternoon. I'm Chris Suver. I'm a distinguished engineer at Amazon. I actually work on Amazon retail side, which we refer to as CDO, which is distinguished from Amazon AWS side. And I'm going to tell you a little bit about how we used Dynamo and how we use Dynamo to basically help us get through Prime Day. And because it turns out Prime Day is kind of a big deal. It was clearly thought of by a marketing guy. That's clearly what was going on. And I'm glad they're thinking about that because I would never have come up with this. And we sold quite a bit of stuff on Prime Day. And the marketing guys love this. They go, this is wonderful. This is a fantastic thing. This is beautiful. Right? We have all these lovely things. Lots of people bought things. 200,000 light bulbs. Right? That's a lot of light bulbs. The developers, on the other hand, see Prime Day a little bit differently. And you can sort of see this. Now, if you look subtly, there's a graph here that I'm going to show you, that if you look at it, you can subtly see where Prime Day is located. And when the developers look at this, it turns out that doesn't look as nice. We don't look at that and say, oh, that's a good thing, right? What we want here is a flat line. It goes straight across, see, and then you have that much space and everybody's happy. Because that makes life easy. We get the right number of servers and everybody works. And, but that's not what they did. So Prime Day was huge. And we have two sides to this graph. You notice on the one side, we're coming in here and then it goes up, which is a good thing, right? And then it comes down, which is also a good thing. But it turns out both of those have a big impact on what you do with your servers that are sitting behind all of this. And the way we really run all of Amazon Prime, as it turns out, is with services. Lots of services. This is a tiny, tiny, tiny fraction. This is just a little bit to get a sample. There are thousands and thousands. And all of those services are operating in order to keep all of our data coming out. All of the stuff is, ideally all of the stuff is these lovely stateless services, right? And that's what everyone wants, is stateless services, because you don't have to worry about anything. And that works really well until you want to remember something, right? And that's state. And that's where we get into databases. Because underneath all these services, underneath these thousands or tens of thousands of services, are thousands of databases of various sorts. And it turns out we use all sorts of databases. Historically, Amazon, very historically, Amazon originally ran on one database instance. That was quite a while ago. That wasn't enough, so they started breaking it apart. And you're seeing some of this breaking apart here. And they broke it apart some more, and they broke it apart some more, and they outgrew it, and they broke it apart some more, and they outgrew it. And they went, huh, right? This is a problem because we're building things that are huge, right? We're building these things and we're running out of space. And we have a problem with this because databases are really, really convenient. And so I'm going to talk a little bit about databases because it's important to understanding how we use DynamoDB and how we use DynamoDB, because it's different. All database systems work a little bit differently. And it turns out the databases come in all sorts of flavors. And we go far enough back. We didn't have relational databases. We had people storing data on the disk, and it was wonderful. And they said, gee, let's fix this. It's a generalization. They started trying a few things. They did ISAM and codicil databases. Anybody know about a codicil database? Somebody must be old enough to know codicil. 2, 3, 4, yeah. Committee on Database Systems and Languages. Hierarchical databases. Predates relational. Totally took over the world, or the banking industry, until cont'd came out with his book and went, oh, it's relational. And he drew these lovely pictures like this green thing here. The top guy there is a hierarchical database. And people looked in the book and they said, this is great, it's a spreadsheet, I can build one of these. And I swear, that has to be how the vast majority of relational systems work, because if you go back and look and say, well, you don't do that. doesn't have to be stored like this. You can store things all nested up if you want. Just logically think about it this way. And this is very important because they didn't. And when they didn't, we got relational databases, which are nice because they're simple. And the relational databases came with a really important feature. They came with transactions. And the reason relational databases come with transactions, and people often think about a database as it's something that has transactions, right? When people think database, you think Oracle, SQL Server, DB2, MySQL, Postgres. There's a whole bunch of things we think of as databases. They all have transactions, so that must be what a database is. And it's not. But you have to have data. You have to have transactions in a relational database. You don't get a choice. You have to have transactions because you've broken your data apart in so many pieces that almost everything you do ends up having to update 2 or 3 things at once. And you want that to look like a single atomic update. And so what do? You wrap a transaction around it. So this is where we got transactions. It gets some other nice properties. It makes the whole thing, makes it a simple and easy to use tool. Right? That's what we've got for our databases. Now, the problem with that is in order to provide transactions, we have to have a central knowledge. We have to have person in control. You have to have a system that understands everything that's going on in the database at once. You have to have one authoritative actor there. You have to have the source of truth. And that's what causes databases like Oracle to end up having sit on one box. And it turns out you can sit on one box, and you can make that really big. And that worked really well for decades. Right? And that's what we built. We built Amazon on that. We built most of the banking industry on that. We built everything on that until we got the internet. And we were all fine if we didn't have the internet, because you wouldn't have that much data, and it wouldn't be a problem. But you start getting the internet, and suddenly you get a huge, vast quantities of data, which you've all run into, which is probably why you're here. And now you have to scale differently. So our scaling, and this is circa 2003, was exactly the diagram you see here. They broke up the database, and they had more relational databases. You take the database, you say, well, this table can be kind of by itself, and we don't actually have to update it at the same time as that table. It'll be fine. And we broke it apart. And that's OK, because now locally I'm OK. Locally, everything is a valid, complete transactional database. And then we do a little bit of work in between. It doesn't happen that often. They have to be coordinated. And everything works, and everything's good. Most of the time. And then, again, as we grew bigger, somebody decided that, well, somebody basically ran into a big enough problem, and they had enough hardware that they rediscovered hash tables. It's amazing, hash tables. Hashing is, amazingly enough, an order 1 algorithm, which is to say, the cost of finding something a hash doesn't care about how many things you have. And they said, this is brilliant. It hadn't been discovered since like 1960. Apparently, it had been buried, and nobody looked at it. And then in about 2000, somebody was digging in the back of the library, and they found this paper, and they were, oh my goodness, we can use this for storage. And we can take all of these things, and instead of having one big server, we'll just take lots of servers, because we have lots of data. And besides which, I've got a whole room full of PCs in the back, and I can wire them all together, because I've got a network now. And they did. And so around 2000, 2003, we got a whole bunch of DHTs. And we got some at Amazon, and it was pretty handy. Dynamo is probably the one you've heard about, which is the distant predecessor for DynamoDB. And this was great, because now suddenly we could scale. We could handle any amount of data, any amount of volume, because we have this nice O1. It doesn't care how many servers you have. Well, it turns out it does. But mostly it doesn't. And we started to use it. Now, it turns out at that time, I worked on the catalog team. Amazon does have a catalog. And a catalog is interesting because we went through this whole process. And we've gone through this process all the way through to today. And it's still ongoing. Because the catalog at Amazon is big. And how many people think I ask this question in interviews. I'll sometimes ask somebody, not as an interview question, just as a point of curiosity, because I'll talk to somebody and they'll talk about, oh, we have this huge inventory, this huge catalog system, and I go, so, how big do you think Amazon's catalog is? And so a bunch of people have answered numbers like, I've had people answer 10,000. And I have, no, it's a little bigger than that. And then I get people and they go, 100,000, hundreds of thousands of things in the catalog. I mean, people think hundreds of thousands. Yeah, you're ahead of me here. So I say, it's great, yeah. Turns out hundreds of millions, because that's sort of what our catalog looks like. That's the stuff inside of it. That's in part of a warehouse, part of a fulfillment center. Yeah, and I actually had to look up, because I don't know today offhand. I haven't worked in the catalog team for a couple of years. Yeah, I tracked down a site on the internet that says just under 600 million saleable items on the Amazon.com website. So it turns out keeping track of 600 million items, keeping track of all the descriptions, all the people that are providing information to them, all the prices, all the people that are buying them, all the people that are searching for them, fulfilling them, right, turns out to be a massive data problem. And it was, in fact, running on a giant server about 12 years ago, 10 years ago. And we broke the server. Yeah, it was big. And it was this is huge. Right? This is a huge SAN with millions of dollars in this thing. And it's like, wow, that's kind of bad. What can we do? Turns out we have this brilliant idea. Hash tables. A DHT, this will solve our problem. And so we started experimenting. And we also looked and said, oh, gee, we have a lot of data. It turns out a catalog item is kind of a complicated beast. And I asked the same question about how many attributes are in a catalog item. Right? And I asked this question, it was interesting. I worked on the Outlook team briefly, and I wondered, well, how many attributes can there be in an Outlook item, in an email address, right? 12, right? No, like 400, as it turns out. And that was 20 years ago. Catalog item, I thought, oh, there'll be hundreds. Once again, this is Amazon. We'd be wrong, right? There'd be thousands, many thousands of properties you can set on an item. And so these items were really big. And it turns out the way they were stored, if you store this in a relational database, turns out not every item has all 7,000 items filled out, all the attributes. My personal favorite is makes whistling noises. There is an attribute, makes whistling noises. Some things make whistling noises. I originally thought it was completely ridiculous, and then I thought about teapots. Some make whistling noises, some don't. Okay, you've convinced me. This is how you get 7,000 attributes. So it turns out the way you get 7,000 attributes in a relational database is use a pivot table. You say, here's my item that has the primary key, and over here is a table that says, here's the item ID, and here's the attribute, right? And here's the value. And then you do a join. And you join the two together, and you pull out 200 rows, or 50 rows, or 700 rows out of the database to retrieve one item. This might be one of the reasons the database was having trouble keeping up. So we went, gee, that's not very good. So it turns out these DHTs also are key value stores. DynamoDB, for example, is primarily a key value store. They've got a little bit of mix. They've got a number of keys that are promoted to top level, and then they've got an all other, which is a great place to put a document. So this is now popularly a document store, because you have a big lump of stuff. And that turns out to be really nice. And if you go back to that relational, you go back to the early days and you say, well, gee, if you think about that right, there's no reason. You can logically think about your data as a relational database, but if we put all this in one package, it turns out we can read and write it in a single unit. And that turns out to be very important when you're working in a DHT. Because when you work in a DHT, you don't get transactions. That single point of authority that you needed to have to make transactions work, right? You don't have that single point of authority any longer, right? Because you've spread it across all these servers. And it turns out you can do distributed transactions. They're very hard. They're very expensive. Most people get them wrong. It's one of the more popular algorithms to look at and go, oh, I know how to do this. I know how to do this. I've got it. And it's right almost all the time. And it's that almost part, right? Almost is really a bad thing. So lumping all your data together, now that I can get right. I can put all of my item data in one bucket, and I can say, write this, and I write it as a blob, I write it as a single record, and it's an atomic transaction naturally because it's a single operation. And that becomes very important in DHTs. Also, I'm only writing one record, right? I'm not writing 200 records. So that turned out to be really, really valuable. So you have to make a few changes. If you're going to use a DHT, and Catalog now uses Dynamo on the front end. On all the inbound side, we use Dynamo. We still haven't replaced some of our historical DHTs that we have internally on the back end. And a lot of those provided lessons for DynamoDB because they had to scale up. It's always nice to be able to do something the second time, but you can look at the mistakes that people made and you went, yeah, that's really ugly. I'm not going to do that. I can avoid that problem. And so they did. So if you're going to use a DHT, and that's the reason and this is what we went through, is you're going to have to change a few things. You have to realize if you're going to pick up DynamoDB, it's not a drop-in replacement for Oracle, and it's not a drop-in replacement for SQL Server. It's not a drop-in replacement for Postgres. Right? It's a different beast. But it gives you scale, and it gives you performance, because that O of 1 is really powerful. Right? The fact that you're reading and writing a single record to get a fairly complex entity is really valuable. The documents and the key value storage is a sparse data model is really valuable when you're trying to migrate things and when you have complex schema. And today, it turns out, for some reason, we keep making things more complicated. We don't take away properties. We add new ones. And then we add some more. And then we have a brilliant idea like Prime Day, and we add some more. And these things get more complicated. And so your ability to grow with that is critical. And that's something that you get out of a key value store. And that's something we've used heavily in the catalog. And that's something that's moved forward in the catalog. But you need to think about your problem differently. So you have to say, OK, what am I going to do? Right? I'm not going to do a lift and shift. Right? You're going to be doing a little bit of a rewrite. We did a rewrite. But I'm going to get a key value store. And I'm going to say, what am I going to do about my transactions? Because transactions, they actually hide multiple things inside transactions. The atomic is one. Well, you get atomic by writing one thing at a time. OK, that helps. There's consistency and isolation, which is basically your multi-user access. You're going to have to deal with that a little bit. Versions are your friend in this case. There's a couple of things to do that. You're going to have to deal with durability, however, you get. And durability is something that comes out of the box with Dynamo, which becomes very powerful. And in fact, they fixed the other part of durability. Durability has two parts. One is you want to make sure when you write something, it sticks. Right? They've had that down. And we did that two ways with the databases, right? Databases are really good at writing it down and having it stick. And they build in backup. Right? Backup turns out to be really important. Backup is actually more important for this. Right? These are fat fingers. Yeah, it turns out they're really dangerous. Right? Most people come equipped with some. And they use them. And your durability on the disk is going to protect you from the machine getting it wrong. But we usually find those things and fix them. It won't protect you from this, because it turns out once a machine makes a mistake, we figure it out, they change it, Machines are not very creative at coming up with new errors. They do sometimes, but generally not. People are very creative at coming up with new ways to break things. And so having another copy someplace else off of that, where when I say drop table, I go, oh, that's not the table I meant. I didn't know I was logged into prod. It's like, oops. And it happens. Having that extra copy, really important. Good news is Dynamo's now doing that. One of the things I was talking about is we actually do a lot of streaming to get data out of there to make extra copies. But they've taken that. We don't have to worry about it any longer. So you have to get data into these things. This is sample data. This is actually sample, a somewhat simplified version, a sample catalog data. This is actually in Ion, as it turns out, which is what we use internally. It looks a lot like JSON. It turns out there are a couple things that are different. Although all JSON is valid Ion, so that works out nicely. But what you get is a document. Right, we put all this together in a nice big document. It makes it easy. That's my single write. That works well. But I also have to have a key. And you notice up here I have the key is this more complicated thing. In this case, the key is the customer ID and the SKU. As it turns out, when you do these hash tables, and you get all these servers, so you can spread them around, the hashing algorithm takes the key and says, OK, which bucket does it go in? That's the right bucket. I put it there. And this is wonderful. If there's some guarantee that it will always pick a different bucket, yeah, it doesn't do that. So it turns out one of the challenges of hash algorithms is getting hash distributions that are uniform. And one thing that's hard to change in your data storage is when you go to change your primary key or your hash key, because you basically have to create a new table and move everything over. So when you're sitting down to actually make the change, you have to say, OK, what is the value? This key works very nicely, because these two numbers are both very large, they're very random, they're very well distributed, and we get relatively uniform distribution, which means we don't get a very large number of records dropping onto the same host. Because when you do that, what you're going to get is what's known as throughput dilution, which is you're trying to get too much work done in a single box. And so you're wasting all the resources on the other box, because we sort of distribute the resources evenly, right? The boxes are kind of all the same size. And so that key turns out to be an important one, which is why I bring it up. I've got a version number in there, because you're going to have two people going and writing things at the same time, and you need to keep them out of one another's ways. And it turns out versions turn out to be a really good way to do that, because you can check them and not overwrite the wrong version. Or you can simply append and keep increasing them and just read the latest version. Right? Both of those are valuable. But I'm really going with denormalized data. I'm really going with a smooth key. And I'm trying to write one record at a time. Now, it turns out that will work when you want to write one record at a time. You will inevitably find cases where you have to write two records. And it turns out this is a good case, because this is information about the SKU. Well, we have information about other things that are closely related. We used to write them both at the same time. In fact, we opened a transaction in one database, a transaction in the other, and we ran down the end. And when we got to the end, we'd go, OK, everything's ready. Commit both of them really close together. That's kind of like a distributed transactions. It's that one that works almost all the time, until it doesn't, and then you got something's broken here. Yeah, redrive that, do it again. It fixes it. In this case, you're going to have to think about that when you write the two records. And one of your big friends for that is, don't do it. Yeah, put them all in one record. That works until this record gets to be too big. The other one is fire up a workflow. Right? Workflows are one of the powerful tools to sort of force to guarantee you get everything all the way through. And what it means is you'll write one of the records. Right? The workflow will have gotten that far, and something will happen. But the workflow remembers where you are, and it'll get on to the next record, and it'll get on to the next record. So you'll at least finish, or you'll get an error. Right? Now, it means your system has to be resilient to the fact that this record was written, and this record was not. So you want to write the customer master record before you write the detail record. Otherwise, you have a detail record that's not attached to a customer, for example. Right? So those are the kinds of things you need to order them. And usually there's an ordering that works pretty well. Not always, and this is not always easy. Right? That's the downside, and that's one of the reasons we have transactions. It's because the developer doesn't have to think about that. Right? But it usually actually works pretty well. The other thing you can do is you can write a manifest. We also do, by the way, we use a workflow in the catalog. So just to be clear, this is how we take care of this problem. We run a workflow, we make sure that it gets all the way through. If it doesn't, we redrive it until it does, right? Or until we get an error and then somebody goes and looks at it. The other thing you do is write a manifest. Remember those versions? This is where they become valuable. I write a new version of this record, I write a new version of that record, I write a new version of this record. I have 3 other records I didn't change that make up this big thing that I'm thinking about, right? And then I write a manifest that says, oh, the new copy is this one, this one, this one, and that one. Because the manifest itself is the single atomic write. And now when you do your reads, you read the manifest, of which there's only one, and then you pick up the versions, and now you've got the entire thing, and it's all synchronized, and you don't get them out of sync. And that turns out to be a very good technique, especially when you're writing fairly large chunks of data. And again, this is one of the techniques we use fairly heavily in order to be able to use the DHTs, in order to be able to use DynamoDB to get consistent systems. And you can also just do it wrong. So the other thing you have to do with Dynamo, the other thing you have to do with it is you have to get the data out. Right? And it's kind of the same data going in, right? But it turns out the other thing you don't get with a DHT typically is select star from where. It turns out not to be very good because it's got to run around to all of those different instances, and that turns out not to be a very happy thing. They'll build indices for you, right? So if you know what you're going to query, this worked great. So in production use, this is not a problem. But for your ad hoc queries, this is going to be a problem. And so one of the things, again, one of the things we do is we make a copy. And part of this came from using this for backup, is we stream the data off, we put it in S3 chunks, and we run MapReduce over it for our ad hoc queries. And that turns out to work really nicely. You could also run it off to Redshift. But your friend here is the Dynamo streams. Because it turns out the Dynamo streams are very nice because they can send the data off and keep up to date your copy that you're using for MapReduce. They can keep up to date a copy that you're using in Redshift or another relational database. They can create secondary indices. Those will all be slightly behind because there's a delay there. But they'll have all the data, and you'll be able to get everything out. Backup was a candidate for that. On the other hand, if Dynamo's going to do backup for you, I would let them do it. It's really, you don't want to have to do it. And mainly because you'll do a really good job of doing backup, and restore is going to be the problem. Restore is really good. Backup's no good unless you've done a restore, and nobody wants to do a restore because I don't know if it's going to work. And say, yeah, that's really good. It's like, oh, wait a minute now. So you didn't want to use the backup to restore your data. So why are you doing it again? So that's somebody to kick is. The other thing you have to worry about is people and operations. The good news here is for operations, you win. You don't have to do as much work when you can say, here, Dynamo, here's the data. Oh, by the way, here's some more, right? That's way easier than saying, oh, by the way, I need 14 more servers. Oh, by the way, I need to move all of this data from my mid-size to my large database, right? That's really no fun at all. But you also have to do work, which means you're going to have a whole bunch of people going, well, why are we wasting our time on this? Right? Why don't we buy a bigger relational database? And the real answer is because you can't. I refer to this design principle of using a tool that has a cap on its performance as designing for failure. This design is fabulous as long as the product fails. It's great. Now, I learned this at Amazon because it turns out Amazon has done a good job at designing things for failure. My favorite example turns out to be the order page, your orders, the list of orders. Turns out when they started, call said, I can't see all my orders. Who would have more than 100? Nobody would have more than 100. We don't want any of our customers to buy more than 100 products from us. It's like, really? It's like, okay, design for failure. That's it. Design for no success. Right? And you're doing that when you drop everything into a single instance database and you depend on the fact that it's a single instance database, the fact that it has that lock table, that it has that transaction manager, that everything is in one single place. When you do it that way, that's what you're doing. Turns out we don't do that. We're actually actively moving all of the data out. Remember the thousands of services? They're not all moved. But we're moving them as fast as we can, and we've moved large quantities of them, and particularly the critical ones, and that's what is sitting in Dynamo, and that's what's getting us out of dying when we come up to that peak. Because the other thing you get in operations when you're operating over this is, you remember we came along with the graph and it was all pretty nice, and then it shot up. It's like, okay, oh. Turns out you come along about here and you go, gee, I'd like some more capacity. Now you're ready. That's good. And even more valuable is you go to the other side and then say, okay, I don't need that anymore. And now you stop paying for it. Right. That turns out to be really valuable. That's really hard to do when you're running your own database instances. When you're running on a big database, it's really hard to move it to a different size database. Right? That's a very large project, and it's not going to be cost effective in this kind of situation. You're just not going to do it. Right? It's silly. Right? But when you can, it's hugely valuable. So I'm going to talk about ordering. Turns out there's other values. The ordering team is right behind the checkout button. When you press checkout, we start a workflow. Customer order workflow was originally. That would be a cow. And the cow system was originally there when I got here. And it turned out I had a little trouble with it. And so they said, okay, we're going to fix this. We have too many cows. Obviously, we need a herd. So it turns out there's a herd workflow engine. It is probably one of the more heavily used workflow engines at Amazon. And it processes these huge orders of incredibly complicated workflows. And they're going to talk about this in a couple days. I'm not going to tell you much about it. But they actually switched recently from keeping track of these workflows in Oracle to keeping track of these workflows in DynamoDB. And a little like Prime Day, I'm going to show you a graph of what happened here, and I'll see if you can catch where this transition took place. And this is the latency. Oh, yeah, that's right. See, over on the left is when we were doing Oracle, and on the right, oh, yeah, that turns out to be about, oh, what have we got about? See, 1, 2, that's some 5, is it 10x? Yeah, it's a little faster. That's a huge difference in performance. And part of that's the get and put. Turns out what you need for this kind of system is get and puts, which are nice, neat packages. You don't need all the overhead, right? And it turns into a really valuable performance win. And what's more is, we go back to that scaling thing. All those orders, guess who had to scale? And so they call DynamoDB and say, we need some more capacity. DynamoDB goes, how much? I say, yeah, that much. And they do it. It works. Now, it turns out if you'd asked me like 3 or 4 years ago, it's kind of interesting they asked me to do this particular talk, because if you'd asked me, and many engineers at Amazon asked me this about 2, 3, 4 years ago, when Dynamo first came out, oh, we got to use DynamoDB, it's brand new, it's the greatest thing on earth. I go, yeah, okay. I'd kind of like to see it run for a while. Granted, they've got a lot of history, they've got a good head start, they get all of the thing, and And it turns out, today, this is a different story. I turn around and go, okay. And now somebody goes to relation database, I go, do you really need to do that? Can you guarantee that your problem is one that is limited, that you're never actually going to outgrow that? And there are some use cases. They're very rare. Right. Wish list was a good example. So you have a wish list. This is another plan for failure. Right? How many items can you have a wish list? How many people are you going to use a wish list? Enough to take an outage, enough to break their database, and they can't do anything with it. Wish list is now using Dynamo. They didn't have that problem this year. They did have it a couple of years ago. It was really about 3 years ago, and they just broke. Right? Plan for failure, designed for failure. This one works. Right? We get the performance. You actually scale your things up and down. The big trick is you get to do this. Right? You get to do auto scaling. You can do regular scaling, you can do auto scaling. You can tell Dynamo to do it and kind of watch when you're drifting up. Let them take care of it, right? So you don't have to fail. Right? Coming back down, let's bring it down. Let's not pay for that. Now, if you know you're going to have a spike, and it turns out the folks in the war room, I have a war room for these big events like Prime Day, because we'd done it before. They knew that it was going to be popular, so everybody gets together, gets ready, and they watch the graph. And I didn't bring this one. And the graph comes along, it's going along, it's all fine, and it's coming up, it's kind of dribbling along, and then it hits and it goes like this. And they go, oh no, we're in trouble. Is it going to go off the end? Panic, panic. Oh, no, we're fine. When you get that steep a curve, you don't want to wait for auto scaling. You want your capacity in there ahead of time. Turns out we did. It all worked. Right? Everybody got a little nervous, but everybody came through it. That's one thing you get to do when you don't have to run your servers. So, Prime Day, we actually had thousands of teams running on Amazon, running on DynamoDB. It turns out 12.9 million requests per second. So that's per second. I have a little plaque. I have a little plaque in my office that I got at a previous place, and it was for TPCC benchmark, breaking a benchmark record. And it says 124,000 transactions per minute. Yeah, that's how far we've changed. Right? That was on a relational database. I was on a cluster relational database, as it turns out, and it was a long time ago. But 12.9 million, that's what we ran for Amazon teams. Right? So this was not Dynamo running, right? This is Amazon running on Dynamo. Dynamo is still running everybody else. We can actually, it turns out, I can now go, yes, I think they can handle the load. Which is kind of nice. I'm still going to complain about things. Like I complain about backup. Now I get to complain about query. Right? It's good. How big an entity can you put in? Some things like that. But they've certainly crossed the line long ago. And they did that in part because we've got a history of 10 years of using distributed hash tables to run systems. Right? And that becomes very powerful. And that algorithm makes things work at massive scales. And pretty much nothing else does. So that is the one that we end up running. So we done early. Prime Day was a big deal for us. We had massive load. We handled it. It greatly exceeded our Black Friday from last year. I don't know how it did against this year yet. I haven't seen the numbers. When you're running something at this scale, trying to run on a single machine, running on a single instance, it's never going to make it. It just doesn't cut it. You're not going to do that. And that's where something like Dynamo lets you scale up and down, and actually scale up pretty much as far as you want. We haven't been able to break it by trying to give it too much load. I'm sure on a given day we can just overload it from what we've requested capacity, but that's how much we've requested. But in order to do this, you're going to need to make some changes. You're going to need to look at your schema. You're going to want to go to a document store. You're going to want to look at your primary keys so that you can operate on the keys properly, so that you get a nice distribution, or at least a reasonable distribution. Right? You're going to want to you're going to want to look at your ACID transactions. You're going to want to look at what you're giving up, because you are giving something up with a relational database. So you need to think about your isolation. You need to think about your multi-user. And you need to think about if you actually have atomic transactions, what do you want to do when you really actually have multiple updates to operate over. And so Amazon grew out of relational databases really 10 or 15 years ago. They certainly grew out of it very quickly out of a single relational database. And our solution has been DHT's DynamoDB today. That's the only way you can get that scale. That's the only way you can keep up with it. And that's just going to be the standard. And I think what you're going to see over the next, we've seen it over the last 5 years, and you're going to see it over the next 5, is the features that we got in a relational database. Right, those features were there because they offered a value to the developers. Things like, for example, backup, atomic transactions, right? Isolation. Those features, query, those features are in the relational database not because they're part of the relational model. They're there because it's a convenience for the programmer. And I think you're going to see all those features show up in the DHTs over time. We certainly have seen it already. The DHTs that we're using today are way more capable, are way easier to use, are way more reliable than the ones that we were using 5 and 10 years ago. Right? It's just no comparison. It makes things a whole bunch easier. And that's going to be what we're moving forward with. And one of the really nice things about DynamoDB in particular is it comes with a SEP field. How many people know what a SEP field is? We got somebody, yeah. Somebody else's problem. Somebody else's problem field. It's kind of like invisibility. You say, how are we going to scale? That's somebody else's problem. I say, no problem. I just go to my little thing and I say, I want more. I'm done. Right? That difference is just huge. That makes a huge difference. So it's a Dynamo talk, so you get a Dynamo slide. We scale. It is really fast. It is managed. It really works. Amazon, we really use it. I wouldn't have told you that 4 years ago. I will tell you that today. We really use it, and it really works, and I'm really thoroughly impressed with how much they're doing, and I will continue to complain to them about the things they're not doing yet. But they're doing the important ones, which is critical, and particularly the reliability and the scalability and the management. So the things that they're listing are things that are real. So I've been very pleased. So I guess at that point I'll say thank you. I'm a tad early. If anybody has any questions, I'll be happy to answer them. Okay. Okay.